Example C. So we're finding the measure of the arc RS. And remember, when we say the measure, this is talking about an angle measure. So we're looking for, and it's a minor arc. Okay, so minor arc is less than 180. So we're looking for this arc measure in degrees. So I'm going to use that top equation again. Okay, and we're going to fill in the pieces that we know. Okay, so the arc length. So we know the arc length is 48. And I know that 2 pi r, the radius is 16. And then the measure of the arc we don't know, so I'm just going to call that x over 360. So this is what I'm trying to solve. I'm plugging in the pieces. I'm trying to find the measure of the arc, and then we can solve. So I'm going to cross multiply, and then I'm going to solve. So 2 times 16 is 32 pi times x. So I'm just going to put that there. And then 48 times 360. Put that in my calculator. $17,280, and then I'm going to divide by 32 pi. Okay, and again, we're looking for degrees, so this is something we wouldn't leave in our calculator. And then again, anything in the bottom that's two things, you do need to group it. So 17,280 divided by the quantity, 32 pi. And so I get that this is 171.9 degrees. Okay, and if you look, you can tell, I mean, we're a little bit less than 180. Okay, so 171 does make logical sense. Okay, so going into some real life problems, it says the dimensions of a car tire are shown. How many feet does the car travel when it goes around 16 times? Okay, so here's what you need to think about, right? When a car travels on the road, okay, from the top all the way around is the distance it travels. And then it's going to do that 15 times. So we're really taking the circumference times 15. Okay, so when we look at this problem, the circumference is 2 pi r. And so I'm looking at this, and we see that the total radius, the whole thing, okay, well, the total diameter is 26, so half of that is 13. So I'm going to go 2 pi times 13, which is 26 pi. So this is how much it does in one revolution, right? The circumference is one time around. And so I'm going to take this and I'm going to multiply it by the 15 revolutions that we're making. And so I get, and I'm just going to plug this in my calculator, I go 1,225.22 inches. Okay, again, paying attention to our unit. But it doesn't want our answer in inches, it wants it in feet. So I have to convert this to feet. So I'm going to divide by 12 inches to get us feet. And I get that I travel 102.1 feet. Okay, continuing on. So it says the curves at the end of the track are shown 180 degrees of circle, right? So it's half of a circle. So if I was to draw in a line through the center and a line through this center, it would be 180 degrees, okay? Half of circles. And it says the radius for one of those arcs are shown, okay? And then it says how far does the runner travel? Okay, so when we're looking at this, we need to figure out how to solve. So if I'm finding the distance, right, I want to do the distance of this half of the circle and this half of a circle. So I'm going to do one full circle plus the two straight pieces of the track here and here. Okay, so let's read this one more time and make sure we're going to solve this correctly. It says, the radius of the arc for the runner on the inner path is shown with a diagram. Okay, so the inner path is shown right here, okay? This is the inside route that we're taking. That's the radius. So if I find one circle, the distance of a circle, that's the circumference, 2 pi r. And I'm going to add the two straight pieces, which in this case is pretty easy. It's 2 times, and they just give you the value. So 2 times 84.39. And so my job is really just to find the circumference of a full circle, that inside path. And so I'm going to go ahead and do that. Circumference is equal to 2 pi, and that radius was 36.8. And then I'm going to add it to that 2 times 84.39. And I'm just going to plug all of that into my calculator, including the pi, everything at once, okay? And I get that their circumference is 400 meters. Right? And we know that a lap around the track is the 400. Okay, last one. A path is built around 4 congruent circular fields. The radius of each field is 99 feet. How long is the path? Okay, so if we think about it, right, I'm going to look at all these pieces of the track quick. Let's just break it down. Okay, here is a quarter of a circle, 1/4 circle. Okay, same thing, 1/4. Same thing here, 1/4. Same thing here, 1/4. All of those add up to one full circle. Okay, so we for sure know we have a full circle. And then I'm going to add these straight pieces here, 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 and here. So we need to figure out what those are. 4 straight pieces. Okay, so let's go ahead and fill in what we know. So I know that all of these radius pieces are 99. So this is another radius. It's also 99. This radius is 99. And this radius is 99. So if I'm looking at this pink mark from the center to the center, this distance up top, 99 plus 99 is 198 feet. So all of these pink pieces, there's 4 of them, and they're all 198 feet long. So I already know the straight pieces. And then again, I know my circle is 2 pi r. That's the circumference of the circle. And so I'm going to go 2 pi, and the radius is 99. And again, I'm going to plug it all into my calculator. And I get that this track is 1,414 feet.